Hello girls! Today we talk about main value theorem. This is section 6.2 in your books. But before we proving one more theorem, okay, I hope it's right, theorem. Let's our function is continuum. It's some function from some interval a, b in real number. And function is continuum in the closed interval ab, and derivative is continue maybe for open interval. Derivative continue for at least for open interval ab. If point C is a relative extreme, point C is relative extreme, extreme point, extremum. If value derivative for this point equal 0. Okay, let's go how we prove this fact. Well, let's pretend C is a relative maximum. Sorry, I forgot here. Relative maximum. And pretend derivative for point C is positive. Then use definition here, our derivative. We have, it will be limit fx minus fc divided by x minus c if x approach to c. Because limit is positive, this means exists some neighborhood point C, such as for any x from this neighborhood, fraction fx minus fc over x minus c, positive. But how we remember fx, sorry, it's not remember how we see, it's simple c, it's not need to be remember, equal fx minus fc x minus c times x minus. If x greater than c, this means factor x minus c is positive and fraction is positive, this means fx minus fc is positive. This means fx, we found some fx, x, point x, in our neighborhood for point C, who is greater than fc. But this cannot be, because C is a relative maximum. Okay, maybe we pretend its derivative is positive is not correctly. Checking what happened if derivative is negative. Now I clear a little bit. This means C is still a relative maximum. Just a moment. And derivative point C is negative. But because derivative is negative, this means limit is negative, this means exists neighborhood, whereas fx minus fc over x minus c negative, and for any x less than c, I see fx minus fc, who is equal fc x minus c times x minus c. Because x less than c, my factor is negative, fraction is negative. This means altogether it will be positive. And we have same problem, fx greater than fc. But c is relative maximum. This means both times where we pretend derivative is point c positive or derivative is point c negative is not working. And we prove derivative is point c is exactly equal 0. Use same method, you can prove if it's you have point relative minimum, derivative will be value derivative will be equal 0 too. Okay, now we talk about main value theorem. But before I clear my desk or something when I try to write. Okay. Sometimes it's take it longer time. Okay. Main value theorem. Theorem. If our function is continue for closed interval AB, derivative is continue for at least open interval AB, then exist at least one point, at least one. One point C from our interval AB, such as value your derivative for this point equal different value your function for endpoint divide by b minus a. We try proof this theorem. Proof. For proving, we build new function phi x, who is equal. We build this function. It will be fx minus fa minus fb minus fa over b minus a times x minus a. What kind of function we have? For example, if you have some function like this is your point A, this is your point B, then function phi will be line who connect these 2 points. This is phi x, black one is fx. Okay. See, checking value our function for endpoint our interval. If we plug in x equal b, we have all simplify, and you have exactly equal 0. If you plug a, you have 0, 2. Use theorem one we proved before for our function. We have point C from our interval AB such as derivative point C equal b minus phi a over b minus a, but we know this is exactly 0. Okay. But if it's mean derivative point f of c minus our fraction fb minus fa over b minus a equals 0, and this means we're proving exactly fact. So we prove this fact. Okay, see one more theorem. It's called Darboux theorem. But first I clear my table. But what we're proving, we can use this fact and have some, I don't know, it's lamb, like if your function continue and have derivative for some interval, and if your function monotone increase derivative, it will be positive for all point increasing. If your function decrease, this means derivative will be negative for this point. Okay, one more theorem. It's called the box theorem, and this theorem tells us if our function is continuous and derivative is continuous for closed interval a b. Okay, if your function f(x) such as continuous function and derivative, we used this symbol before, and k some number between value your derivative your function for point A and value derivative your function for point B, then exists at least one point C from our interval AB, such as derivative value derivative your function for point C equal K. Oh, here we have two numbers, f prime A and f prime B, because one is less than another. Now let's go. We have f prime a less than k and k less than f prime b. You can build maybe it's inequality is opposite side, but it's not no big deal for proving. Build new function gx who is equal kx minus fx. Derivative of this function will be k minus f prime x. And if we plug in point A and point B, we have g prime from A, it will be k minus f prime for A, and we know it's positive. And g prime for B, it will be k minus f prime for B, it will be negative. This means function is increase and then function is decrease. From here we have exist point at least one c such as g prime c is need be equal 0 because our function f is continuous and function j this means is continuous. If g prime c is equal 0, this means k minus f prime c equals 0 and f prime c it's exactly equal k, what we need proof. Okay, great. Now we're solving two examples what we studied today. Oops, I can use only one finger for crying. I try to make it something faster, but it's not working, sorry. Okay. Take it longer time. First question is what's this? Found relative maximum and minimum our function in domain and found interval where our function increase and decrease. We have our function is x plus 1 over x. Here you can see domain this function any numbers except 0. Found derivative here. You have 1 minus 1 over x squared. It will be x squared minus 1 over x squared. If we factoring, it will be x minus 1, x plus 1, divided by x squared. If we plug in our x-axis all zeros, but remember here we have open point 0, this means point where is our function and derivative of our function not exist, point 1 and point negative 1 and point 1. Use interval method, we can easy plugging for derivative function. Interval where is our derivative positive, negative, positive here. If you plug in some point greater than 1, between 0 and 1 is negative, between negative 1 and 0 is negative, and less than negative 1 is still positive. What do our function f? We remember we talked. Use main value theorem, we can see if it's our derivative is positive, this means our function is increase. If our derivative negative, our function is decrease. And here is increase. This means negative 1 is relative maximum, 1 is relative minimum. If you see for function point is -1, it will be -1 minus 1, it will be -2, and this is a relative maximum. Value function for 1, we call 1 plus 1, it will be 2, and this is relative minimum. Okay, here it's example where its function maximum is less than minimum. It's happened because our function is not continuous. We have two pieces of graph, and it's happened. Okay, great. One more question, one more example. I'm clear here. Example where I try prove something. Here we try prove this kind of inequality. Sine absolute value differ between sine x and sine y less or equal difference between absolute value between difference between x and y. Okay, this is more correct. How we prove this fact? We need to use main value theorem. Let's go our function fx is function sine t. Oh, it cannot be fx sine t. Okay. ft sine t. Then for any interval xy exists point C such as derivative for point C equal sine y minus sine x divided by y minus x. We use main value theorem. But what is derivative sine? It's cosine. This means here I have cosine c times y minus x equal sine y minus sine x. Because it's true for here I can plug in absolute value. Now I tell you after what I need absolute value. Absolute value cosine c multiplied by absolute value y minus x equal sine y minus sine x. Cosine function whose values stay between -1 and 1. This means absolute value cosine c, it's less than 1, less or equal 1. If I skip this factor for my left part, my inequality, this means I substitute cosine c for 1. This means I make it left part, my equation, greater than right part. And this means we from equation move to inequality. And we have absolute value y minus x greatest or equal absolute value different sine y minus sine x. Now this x minus y or y minus x is absolutely same. This means we prove this fact. Okay, we're done for today. Have a good day.